largest candidate rule. But because of this digital board, which I was using for the very first time yesterday, I found it a little difficult to manage things. So today I'll be just repeating the same thing again, the first problem that we have discussed under largest candidate rule. I'll quickly just go through it and try to explain it in a better way. And then we will discuss one more problem today based on the Kilbridge and Wester method. So at least till here, you will have for your second internal, that is largest candidate rule and Kilbridge and Wester method. The last method that is there, the rank positional weight method, that may not be there for your second internal, but you can expect the syllabus that I'm covering today can also be a part of your second internal. So yesterday we were. Is the presentation visible? Is the screen visible?
Yes, ma'am.
Okay. So yesterday we were discussing the largest candidate rule, and this was the problem. I even asked you all to note down this table. Then the very first step when it comes to largest candidate rule is you have to rearrange the complete table with respect to the TEK values in the descending order. So this was the table. We have here you can see that the TEK values are rearranged, and all the corresponding work element and the precedence are also rearranged in descending order with respect to the work element time values. Having done this, the next step is to draw the precedence diagram. So precedence diagram, as I said, it moves from left to right, and from this table that is there, you have to follow the precedence. This table, or you can refer to this table, the first table that was given. Of course, you'll have to refer to this first table, and based on this, looking into the precedences that are mentioned. Precedence means what? Before you complete the task, the first task, you cannot proceed to the second one. So that has to be taken care of. So when you see this table, when you see the first work element and the second work element, they do not need any precedence. They do not need any work to be done before, right? So you can start with these two, and then if you see third, it requires the first to be completed, and so on. So these things we have discussed yesterday, and I even used the board and tried to explain you the same. If you have any doubts understanding precedence diagram, we can discuss it once again. So should we discuss this once again, or we'll just proceed to the next step? Because this precedence diagram, it is all based on a few iterations. You just cannot have the precedence diagram drawn at one go. Okay, so maybe anybody, even the person who has learned the precedence diagram well, or even the beginners, you will have to go for some changes to be made here and there. The way you're going to place all the nodes and all the arrows, all of those things have to be understood and taken care of when you start drawing the precedence diagram. So with practice, of course, you will be able to draw this, and I believe you are going to study the same in operations research also, where you'll have a better practice about these precedence diagram. So I'm not going to worry much about drawing the precedence diagram because it's just a part of this. Um, we are not studying precedence diagrams or anything like that in this subject. It is just a part of a problem. So believing that you are going to study this in a better way in operations research, I'll proceed with my discussions. So this is how you're going to place the nodes and all the arrows based on the inputs from the problem statement. So this is the second step. You have the precedence diagram drawn. After this comes the most important thing. These are the steps that you have to follow once you finish the first two steps. Here it is basically all these line balancing algorithm. We are aiming at allotting the work elements to a particular station in such a way that all the work elements that will be allotted to the different workstations should have almost same amount of work to be done at every station. The worker who is there at every station should have same amount of work to be done. That is like we are trying to go for an equal distribution of work, but and completely equal distribution of work may not be possible, but at least coming close to that can be possible. So what is the limit that we are going to set? Like at every station maximum you can have the service time um, kept as the allowable time, so that there can be a uniformity maintained. So you cannot have at every workstation you have some random, for random time you're going to work. No, at every station there is going to be some fixed time for which you're going to work. So for us here, that time is going to be the station time. We call it as a station time, which is nothing but the service time. Okay. So in the problem statement also here, you can see you have to find the. Yes. So we have solved these the problem based on these equations. So we have TWC, we have TC value. The cycle time value is 1.08, and cycle time is nothing but the service time and the repositioning time. So what will be the service time? We have already found out. So based on this, yeah. So available service time, you can see here. The available service time is 1 minute. This is our reference point. So this time has to be taken into consideration while you allot the work elements at every station. The allocation should be done in such a way that the total TEK value should not exceed 1 minute. Okay, this is the maximum time at every station. And based on this, you can go for distribution or allotment of those work elements at every station. So precedence diagram, after precedence diagram, we follow those steps. First is what? Assign elements to the worker at the first workstation by starting at the top of the list and selecting the first element that satisfies the precedence constraint and does not cause the total sum of TEK at that station to exceed the allowable TS. So allowable TS is here 1 minute. When an element is selected for assignment to the station, start back at the top of the list for subsequent assignments. And next step is when no more elements can be assigned without exceeding TS, then proceed to the next station. And then repeat step 1 and 2 for as many additional stations as necessary until all elements are assigned. So how do we do this? Is this visible? Is the whiteboard visible?
No, ma'am. Yes, ma'am. Now it's visible.
No? Okay. So this is the table that you all have already with you. We are discussing the largest candidate rule only. Yesterday we were discussing the third step, which I could not really manage well with this whiteboard, but I hope I can do that today. So here, this is the table of after rearranging the all the columns in the descending order of the TEK value. So this table everybody has. Now the next table that you see here is the solution table actually. Okay, with the help of this table, which is on the top left corner, you will be getting the solution here. All the allocations are done here. So this table gives you the work elements assigned to station according to the largest candidate rule. Now, how do we do this? So as it is said that after arranging this, you have to get the columns made such that you can find out the number of stations required in order to complete this task. The complete task of that small electrical appliance that has to be made can be Done. How many workstations will be required? That is the answer. That is what is required here. So to start with, you are first going to write these columns: station, work element, TK value, and station time. So station time here, it should not exceed the allowable service time. And that allowable service time is how much? It is 1 minute. Okay. So here, let us start with first writing station 1. After that, let us now refer to this table. Let us see which has the maximum TEK value. Okay, we have work element 3 having the maximum TEK value. TEK value is zero point 0.7. Is it exceeding the allowable TS value? No, it is not exceeding the allowable TS value. So here allowable TS is 1 minute. You cannot exceed that. Now if I start from this TEK, does it satisfy the condition of allowable TS value not exceeding 1? Yes, because it is zero point 0.7. But precedence, we cannot start with allocation of third work element because first is still not complete. Okay, so based on this precedence constraint, if I start moving downwards here, I see that work element 2 TK value is zero point 0.4, which satisfies the condition of allowable TS value not exceeding, oh sorry, the work station time not exceeding 1 minute. Yes, this is taken care of. Plus, do you need any precedence here? You do not need any precedence. So first, I will allot or assign the work element 2. And once I do that assignment, I will just strike off this work element from my allocation so that I don't reallocate it anywhere here. So in the first station, I can start with work element 2. Okay, having TK value as zero point 0.4. Okay, still I have scope of allotting or assigning some other work element because I have an allowable station time of 1 minute, whereas I have only utilized zero point 0.4 minutes. So let me again go for some new assignment or allocation. For that, I just cannot start moving from 2. I can't see what is, I just cannot move to see what is the 10th work element or 7th or anything. Once I strike off 1 or once I assign one work element, I have to start back again from the top of the list. I just cannot continue anything from where I had stopped. I have to start again from the top of the list. So now let us again think of 3. Can I go for allotting 3 at that workstation? Can I do it? It is zero point 0.7. If I add zero point 0.4 and zero point 0.7, what will be the sum? It will be 1.1, which will exceed this allowable TS value by 1 minute. So I cannot allot this. And also the precedence of 1 is not satisfied. Can I allot 8? I cannot because 3 and 4 precedence is not taken care of. 11, I can't. 9 and 10 precedence not taken care of. Can I go for 10? No. 7, I cannot because 3 precedence is 5. Can I go for 5? Okay, 5. It is the TK value is zero point 0.3. Yes, zero point 0.4 plus zero point 0.3 is going to be zero point 0.7. What about precedence? 2. Yes, we have already taken care of the second work element. So of course I can allot the fifth work element to station 1. So once I try to allot that, I will just strike off this work element so that there is no reallocation of it. So can you see here? We have the fifth work element assigned here, which is having TK value is zero point 0.3. So the sum is zero point 0.7. I have more scope of allocation. So once I strike off this, I cannot continue. I have to again start from top of the list. Now 3. Yes, precedence not satisfying plus zero point 0.7 will exceed the allowable TS value. So I cannot go for 3 nor 8 nor 11. Can I go for 10, 7? No. 9? No. What about 1? 1. Yes, I can go for 1. 1 because the TK value is zero point 0.2 and there is no precedence required. So once I allot this, I'm just going to strike off and you have 1 here. Because zero point 0.4 plus zero point 0.3 plus zero point 0.2, it is how much? It is zero point 0.9. So I still haven't exceeded the allowable TS value of 1 minute. Now let me go back again from start. I cannot allot zero point 0.7, though I have taken care of this precedence 1 now. TK value, if I add zero point 0.7 here, it is going to exceed this allowable TS value of 1 minute. So I cannot allot 3. What about 8? No, 3 and 4 have to be taken care of. Likewise, if you go on checking, you will finally observe that 4, which has a TEK value of zero point 0.1. If you add zero point 0.9 and zero point 0.1, it will be 1 minute, right? And the precedence of 1 and 2, yes, that is also already taken care of because the work elements 1 and 2 are already assigned. So 4, the work element 4 can also be assigned to workstation 1. So if you see here, the total sum of these 4 work elements will be less than or equal to 1 minute, right? Therefore, at first workstation, you can have 1, 2, 3, and 4 work elements assigned. Understood the first step? Yes. Anybody there to reply?
Yes, ma'am.
Are you following, understanding what I just told? Are you understanding what I just told? Yes or no? Shall I proceed or stop here? Nikhil, Yash, Bichu, shall I continue?
Yes, yes, ma'am.
Okay, the screen is visible, right? Please reply fast.
Yes, yes.
Screen is visible. Okay. So once you complete the allocation of one station, now we will proceed to the next one. So again, you'll have to start from the top of the list itself. Let us go for element 3, work element 3. It has a TEK value of zero point 0.7 and precedence of 1. Yes, precedence of 1 is taken care of and TEK value is also less than 1 minute. So I can go for assigning work element 3 to the next workstation because the first workstation is full. You cannot add more work elements to station number 1 because the allowable TS value is 1 minute and we have already got the total time as 1 minute. So now let us go for station 2. You have to now have a new station. Station 2, first element is third, the work element 3, and we have assigned it already. Now, once this assignment is done, again you start from the top of the list. So third is gone. Let's see if 8 can be assigned. 8 is zero point 0.6. Of course, the sum is going to exceed 1 minute, so we are not going for that. Same with zero point 0.5, you cannot. What about 10? If you go for 10, it is 0.38. Still, it exceeds. 7, it is 0.32. It is exceeding. 9 is 0.27, but yeah, we can have 9, but it needs a precedence of 6, 7, 8. We cannot go for that as well. What about 12? It is zero point 0.1, but precedence of 11 required. No, we can't. 6 is 0.11. Yeah, it is 0.81 and 3 precedence. So 3 is already taken care of. So we can allot work element, or we can assign this work element 6 to station 2 because it satisfies both the TEK constraint and the precedence constraint. So we have assigned it here. So if you see 0.7 and 0.811 is going to be equal to zero point 0.8. So at second station, this is what you get. It will be equal to 0.88. Right. Now, the third station. Now, do you want to have some additional other allocations? Let's see if that is possible. We have assigned it till 6. Now, again, I have to start from the top of the list. So, 6, 8 can I assign 3 and 4? But what about zero point 0.6? It is exceeding 1. I cannot. What about this? No, I cannot. If you check out for any other TEK values and the precedence constraint, you will come to know that you cannot have any other additions or any other assignments made to station 2. So you'll have to wind it up here itself. Now let us go for a new station. At station 3, so you write it as station 3. Let's start a lot the assignment. So here first is 8.6, 3 and 4. Yes, stations work element 3 and 4 is already taken care of. Yeah, so we can assign station, sorry, work element 8 at station 3. So that's what is here. So you have 0.6. Now again, start from the top of the list. 3 done, 8 done. What about 11? Can I assign 0.6 and 0.5 is going to cross the 1 minute limit. So I'm not taking 11. What about 10? Yes, I can take 5 and 8 have to be over. Yes, 5 and 8. All these, both these constraints are already uh, taken care of. So you can have this assignment of 10th work element to third station. It is 0.38. What is the sum of this? It is 0.98, well within the allowable TS value. But do you want to add anything else? If you try to add anything else from this list, you will either have a precedence constraint or maybe the sum is going to go beyond 1 minute. So you can just stop the allocation for third workstation here itself. The sum of it is going to be equal to 1.98. Now, still there are so many elements pending. So let us go for one more workstation, that is fourth workstation. Let's start the allocation from from the top of the list. Can I allot 11? 11 needs 9 and 10 to be allotted. Are 9 and 10? No, still 9 is not allotted anywhere. Okay, so let me go. 2, 10, all of these are already allotted. That will not be taken into consideration. What about the seventh one? Yes, I can go for assigning the seventh element because the precedence constraint is satisfied and also the TK value is 0.32. We can consider. So I'll place 7 here. 0.32. Now, again, I'll have to start from the top of the list. 3 done. Okay, 11 I can't because 9 and 10 have to be satisfied. 2 done, 10 done, 7, 5, 9. 9, what about 9? It needs a constraint of 6, 7, 8. Yes, we have already taken care of 6, 7, and 8. So I can assign work element number 9. So this is what is placed here. It is 0.25. Okay, now let me check again if I can place anything because the total now is 0.59 only. But if I try to place 11 here, 0.59 plus zero point 0.5 will exceed 1 minute. I cannot assign 11 to that workstation. All others are assigned. Left is 12. It is 0.11, but it needs a precedence of 11. So I cannot assign 11 nor 12. So we will have to end it here itself. So the total here is going to be 0.59. Now left is what? 11 and 12. Again, start from the top of the list. 11 I can because 9 and 10 constraints. Yes, we have already assigned it. So the precedence constraint is done. And also the TK value. And then if you go down again in the list, left is 12. Now this is the final assignment. So while you solve the problem also, you can use a pencil and just start striking off all these work elements which you have already assigned in order to avoid the confusions. And also the examiner will clearly understand that you have properly assigned all the work elements following the proper procedure. So this is how all the assignments have to be made. And based on this, the table that you have written, you can understand one thing, that the number of workstations that will be required here for in order to complete um this task is going to be 5. So you have 5 stations that will be required. So once you know the number of stations, now you can find what is the balance efficiency, line balance efficiency, which is given by TWC upon W into TS. Right? So we know TWC value. Now we know what is the number of workers required. It will be 5. From this table, you can understand that you require 5 table, and TS value is already known to you. Substitute all of that, you get the efficiency as percentage. Is this clear? Is it clear? Is it understood? Okay. So the next final step is in the precedence diagram that you all have already drawn. You're just going to group all the work elements into boxes which represent the workstations. So if you consider the first one, uh, if you consider the table here in which you have assigned the works for our first workstation, you have elements 2, 5, 1, and 4. So if you consider here 2, 5, 1, and 4, you have it here. You have 2, 5, 1, and 4. So you can just at random put them, not at random, of course. all of these stations have to be then put into a so this will represent the workstation 1. What about workstation 2? Workstation 2 has elements 3 and 6. So here we have element 3 and 6 here. You can enclose this into a box like this, which represents the element 3 and 6 as the work elements assigned to station 2. What about the third one, where what are the work elements at workstation 3? It is 8 and 10. So at 8 and 10, we have it here. 8 and 10 is here. So you can just this is workstation 3. And then at fourth workstation, you have 7 and 9. So let us assign those. Yes, we have 7 and 9 here. And the last left is station 5, which have work elements 11 and 12. Okay, so here you can just write station 1, station 2, and so on. So you have station 1, next is going to be station 2. Station 2 is here. This will be station 3. Station 4, and this is station 5. So this is how you can group all the work elements into their respective stations, and you can show them here. And also finally, there was a different table also which was shown. You can just draw these boxes which represent all the stations, all the work elements grouped into stations. This will be your station 1, 2, so you have all the stations 1, 2, 3, 4, and 5. So in this first station, what are the elements that you have? You have, I suppose, 2, 5, 4, 1. Then here you have 6 and 8. Here 2, 5, 4, 1, 3 and 6, 8 and 10. 3 and 6. Here you have 8, comma 10. Then you have 7 and 9 and 11 and 12. So these are the stations. Okay, so this is how you have to solve the largest candidate rule. Once you get this, so once you have solved that, after the precedence diagram, you do the assignment of all the work elements at different stations. So this is how you have all the assignments done. And then finally, you have to assign, just show this assignment of elements according to the largest candidate rule with the help of the precedence diagram. And then this is the final thing that I was just showing, that is the physical sequence of assignment or physical sequence. One second. Okay, physical sequence of stations with assigned work elements. Having done this, you have to find what is the balance efficiency. In order to find balance efficiency, you know what is TWC value. W is what you have found out from that table, that is number of workstations is equal to 5, and TS value is already known to you, that is 1 minute. So based on this, you get balance efficiency as 80% and the balance delay of 20%. So now moving on to the next method, that is Kilbridge and Wester method. So here, work elements are assigned to stations according to their positions in the precedence diagram. Okay, are you all there, listening, understanding? Shall
Yes,
I
ma'am.
proceed?
Yes, listen.
So moving on to the next method, that is Kilbridge and Wester method. The work elements are assigned to stations according to their positions in the precedence diagram. Here, this overcomes one of the difficulties with the largest candidate rule, in which an element may be selected because of its highest TEK value, but irrespective of its position in the precedence diagram. Yes, now when we were allotting or assigning the work elements in a largest candidate rule, we were concentrating more on the descending order. Okay, when it came to precedence constraint, yes, we considered it, but things were not completely based on those precedence constraints. We were more concentrating on the TEK values. So in general, Kilbridge and Wester method provides a superior line balance solution to that provided by largest candidate rule. In Kilbridge and Wester method, work elements in the precedence diagrams are arranged into columns. So these are the steps. Let us see what are these. First is you have to put all the work elements into columns. Next is the element can be organized into a list according to their columns, with elements in the first column listed first. Next is, if a given element can be located in more than one column, then all of the columns that for that element should be listed. Here the element in a given column are presented in order of their TK values. That is, we have applied the LCR within each column, largest candidate rule. So this is helpful when assigning elements to stations because it ensures that larger elements are selected first, thus increasing our chance of making the sum of TK in each station closer to the allowable TS limit. So almost all the procedure here also would be the same as we have seen for largest candidate rule, with few changes here and there. Here, Once the list is established, the same three steps procedure is used as before. Okay. So this is how it is. I will just show the same with the help of the board now. Okay. Uh, is the board visible now? Yes.
Yes, yes.
Okay. So we are solving the same problem statement, all the given data is same. Where I said for the previous problem, apply largest candidate rule. Now we will be just adding a statement saying apply the Kilbridge and Wester method. Here also you are going to find the same thing. You have to find what is TWC, what is TS, what is RP, what is whatever else is asked. You have to find all those things. And at the end, you have to find what is the line balance efficiency. In order to find the line balance efficiency, you need to find what is W. In the previous problem, we used to find the theoretical minimum number of workers, which had a formula. Now we want to know the actual number of workers with the help of all these methods. Okay. So in order to find the number of workstations or the number of workers that we want, that is W value, we will go for these methods. So the very first step in Kilbridge and Wester method is you have to draw the precedence diagram. So you already have understood how to draw the precedence diagram. Having done that, the next step here is to put the work elements into columns. Now, how do we do that? We do that here is we after you draw this precedence diagram, keep the precedence diagram as it is, and you're just going to put it into columns. So the work elements that are placed one below the other will be put into the columns. Therefore, we have all these work elements arranged systematically in precedence diagram. We will be using it further, and this is actually how the precedence diagram has to be drawn. But because of that systematic thing followed, it becomes easy for us to put all these work elements into columns. So you can just put it like this in columns. So just imagine if you had drawn the precedence diagram randomly, placing the work elements anywhere and you not using these straight line arrows, then proceeding with this method can be difficult, because in Kilbridge and Wester method you have to use the columns in order to you have to put these precedence diagrams in columns in order to proceed with the problem. Okay, so this is how you're going to put them into column.
Ma'am, you're not audible.
Yeah, because I'm not speaking anything. I'll just finish with this column.
Okay.
Am I audible now?
Yeah.
Okay. So I request you all also to just simultaneously solve the problem along with me. You have the precedence diagram drawn first in the same precedence diagram, or you can just redraw it again. And in that precedence diagram, you can just put all the work elements into columns like this. Once you put them into columns, now you can just name these as okay. So this is how you're going to put all of these into column. Is this step clear? The first step for Kilbridge and Wester method, first is you'll have to draw the precedence diagram. Once you draw the precedence diagram, you are going to place columns to all those work elements which fall one below the other. So this is the first step in Kilbridge and Wester method. So in Kilbridge and Wester method, work elements in the precedence diagram are arranged into columns, and the elements can be organized into a list according to their columns, with elements in the first column listed first. Now let us try to understand what is the next step. So having understood this, let us move to the next step. In next step, what we have to do is, with reference to this, you have to make another table of work element, column, TK value and preceded by. So please draw this. Yes. So have you all written down this? I hope the column is ready. Okay. So you have to make another column with work element, column, TK and precedence. So first, let us start with column, okay, wherein we will first proceed with the first column values. So in order to put them into first column, if you can see here, in the first column, which are the work elements, you have 2 and you have 1. These are the two work elements. But under each column also you'll have to apply largest candidate rule, that is you have to place them in descending order. So first you will be placing work element 2 and then you will be placing the work element 1, because it is zero point 0.4 and then it is zero point 0.2. So that's how you're going to write this. In column 1, first you're going to have column 1 work element 2 having TK value as zero point 0.4, precedence it does not require. Then comes work element 1, column 1, TK value zero point 0.4. So here you can see we have followed the descending order for first column. Precedence also has been written. So precedence, you follow whatever corresponding precedence preceded by values are there or the numbers are there. You just write them as they are. First thing you have to remember is you have to start with first column, then second column, then third column, and so on. But when it comes to assigning these work elements to that particular column, it depends upon the descending order of TEK values. So moving on to the second column. Second column, you know there are how many work elements in second column? 1, 2 and 3. We have 3 work elements. So first you are going to assign 3, then 5 and then 4. That's how we are going to place it. So for you have written column 2, 1, 2, 3, three elements. First we have placed 3, 5 and 4. Why? Because it is zero point 0.7, zero point 0.3 and 1 and the corresponding precedence values, constraints. Okay, so this is how you place it. Next is third column. Let us see how many elements are there in third column. It is 1, 2, 3. We have 3 elements. Here there was one note which said that if the given element can be allocated in more than one column, then all the columns for that element should be listed, as in case of 5. Now we know element 5, it is having, oh sorry, 10 is having a precedence of 5. So the same 5, if you want, you can even write it here. Okay, if you have this additional allocation which actually does not create any, does not have any meaning here, but just so even if you're showing this element 5 once more here, it still will not. Okay, so if you have any element shared in between two columns, whenever there is a gap, even that is allowed. But when it comes to adding the elements to this column, we will not be adding it here. If you can see here, you have column 3, you have only 3 elements, but just to show it there, you can just put it as a dummy node in the precedence diagram. Okay, so here again we are following the descending order, zero point 0.6, 0.32 and then 0.11 with corresponding precedences. Next comes is column 4. Column 4, it has two elements, 9 and 10 precedences, descending order, zero point 0.3 and 0.27. So 10 and then you put 9. So you can see here for column 4 you have 10 and then 9, 0.38 and 0.27. Next is column 5. It has only one element. Column 5, it has only one element, zero point 0.5, and then 6 is 12th element, that is zero point 0.12. So this is how you are going to rearrange the complete table with respect to work element, column, TK and preceded by readings or the data, such that first you start with column 1 and this goes in the ascending order, but at every column you consider the TK values in the descending order and you make this table ready. Once this table is ready, then you go for the final assignment of work elements to workstations. So this table here, it shows the work elements listed according to the columns from the precedence diagram. So once this table is ready, you get the final table. Okay. So how do we get this? This basically is a table which has work elements assigned to stations according to Kilbridge and Wester method. So let us again start with station, work element, column, TEK and station time. So it is similar to largest candidate rule problem itself, but only column is one extra additional consideration that we have taken here. So here also we have again the allowable TS value. So all the assignments that we do to every station should be well within this allowable TS value. It should not exceed 1 minute. So let us start with first station, station 1. Station 1, first you have to consider the column 1. In column 1, you have zero point 0.4, yes. So the column thing is taken care of, zero point 0.4 precedence is also taken care of, fine. So you first go for allotting or assigning the work element 2 to station 1. once you allot this, you just strike it off so that there is no reallocation. You write work element 2, column 1, TK value. Next, let us see if you again you'll have to start from the top of the list. It's 1. It is again in column 1. So you'll have to try and see that you first finish the columns. So next is you can go for assignment of 2 because sorry, assignment of work element 1 because again it belongs to common column 1. TK value is zero point 0.4, so sorry, zero point 0.2. So zero point 0.4 and zero point 0.2 is going to be zero point 0.6, not exceeding the allowable TS value. And also the column 1 is completely taken care of. So still we have scope because we have not exceeded the allowable TS value. So again, let us start from the beginning. Okay. Third column. Can I have third column, third work element added? No, because the TK value is zero point 0.7 and it will exceed the allowable TS value. So let me see 5. 5 belongs to column 2, yes, zero point 0.3. I can add zero point 0.3. So, and the precedence is also taken care of. So, here it is. Second, first, and fifth elements have been allotted or assigned. Now, let us see again in this column 2. In column 2, can I assign zero point 0.7? No. Can I go for 4? It is in column 2, zero point 0.1. Yes. So, the new assignment to workstation 1 will be a work element 4. Now, if you see the total of this, it will be 1 minute. Any addition done beyond this will exceed the allowable TS value. So you'll have to stop the allocations here itself. So at first workstation, you can have all these 4 work elements assigned to the first workstation. Next, let us start with the second station because we have to completely assign all the work elements that are there in the list. Now, again, I have to first do away with the second column. So let me start with third work element. I will go for assigning this. So I have third work element assigned, which is from column 2, and the TK value is zero point 0.7. Okay. Next. Now we have to see in column 3. In column 3, we have 8, which is zero point 0.6, which will exceed 1 minute allowance. What about 7.32? Can I have 0.32? No, still it will exceed. Can I have 6? Yes, I can have 6. It is 0.11 and it will not exceed the allowable TS value. So I'll have 0.11 assigned here. Any further addition can I do? So the sum is 0.81. Can I do any further addition? Can I do the addition of 12, that is 0.12? Can I add it here? I could have, but then it comes in column 4 or 6. So first I have to follow the column sequence also here. I just cannot concentrate on the precedence here. Rather, I will have to concentrate more on the column and then the TK values in the descending order. So now this cannot be done. So we have to end it here itself. The allocations will be stopped here itself for station 2. Now let's start with station 3. Now again, see column 3 first. I can start with 8, that is zero point 0.6, and then I can also go with 7, that is 0.32. So the TK value sum is not exceeding 1 minute. And do I have to add anything else? I cannot because it is already 0.92. Anything added further will cross the 1 minute allowance. Now let me go for the fourth workstation. I have to take a new workstation. Let me start with element 10. Yes, I can take 10. It is 0.38. So I can allot 0.38. Next is from the fourth column itself in the descending order, ninth element can be assigned. After I assign, I'll just cancel it off, strike it off, and then finally add. Okay, so this is going to be 0.65. If I'm adding zero point 0.5, it is going to be crossing the one limit, sorry, 1 minute allowable TS value. If I'm adding 0.12, I cannot add it because before I go to 6, I have to assign this fifth column element. So I cannot even add 12 here. So let me start with the new station. I'll go for assigning element 11 with zero point 0.5 as the TK value, and then element 12 with 0.12 as the TK value. So these assignments are done here. So like this, all the work elements have to be assigned to one or the other station, and every method will have their own constraints, own considerations when you go for assigning them. So based on this also, the total number of workstations W, the number of workstations W here will be 5. You can use the same in your line balance efficiency equation of EV given by TWC upon W into TS. And again, you will get the same line balance efficiency of 80% here. Okay, so this is just another way of going for assigning these workstations. So this method basically it is helpful when assigning elements to stations because it ensures that the larger elements are selected first, thus increasing our chance of making the sum of TEK in each station closer to the allowable TS limits. So things are almost similar as you have done in the largest candidate rule. But only thing is here in the very first step itself, you consider the precedence constraints and the TEK values and then further proceed with the assignment of work elements. Whereas when it comes to largest candidate rules, we were mainly concentrating on the TEK values. So this method is one which provides a superior line balance solution as provided by the largest candidate rule. But please note one thing, in our problem, you will see that there is no superiority proved here in the largest candidate rule or this Kilbridge and Wester method, because in both the cases, the line balance efficiency is remaining 80% itself, right? There is nothing change that you can see. But all these problems, no, all these methods that we are talking about, these are dependent on the problems statements or the problems that we have. So performance of the given line balancing algorithm, it depends upon the problems that need to be solved. So some line balancing methods work better on some problems and some may like you can have these different methods working best for certain type of problems. So as we are considering just one problem and explaining all the three methods, the comparison of one method being superior than the other may not be proved very well with our one problem statement taken to explain all the three. Okay, so as and when the problem statement changes or the data changes, maybe the superiority can be explained better. But as we are explaining the whole thing just with one problem, you cannot compare the methods here with respect to this one single problem. Okay, so I hope this is clear. These are the two methods that I wanted to discuss today, and we will stop here. For your second internal, you have all of this in your syllabus. You have second unit half that was not there for first I, and this third unit up to the Kilbridge and Wester method. You will not have ranked positional weights method that we will discuss in the next week after your internals. Okay, so 6, 17, 18, 19. So next week I'll not be getting any class. Um, So let's see, whichever is the next class, I will just finish with this rank position weights method, and then we can continue with the next unit. The notes with respect to this unit, whatever notes I have and whatever presentation I have, I will share that. We are just waiting for some notes from Sachin sir to give the notes of this unit. So as and when we receive those, we will share the same with you people. So shall we stop here? Because the first and the second unit notes I was supposed to write, so I have all those. We had split the note preparation part in between all of us. So we are just waiting for Sachin sir to give his notes. Once I receive, I'll share the same. Shall we stop here?